4.3, writing equations of quadratic functions. Well, we've already learned all this material. Now we're just kind of coming up with the equations. So let's look at reviewing three things first. So first, let's review standard form. If you remember, standard form was ax squared plus bx plus c. Well, vertex form had the a factored out front, and then x minus h squared, and then plus k, where hk was the vertex. And then the factored form with the roots form, which can also be called root form, it's a, and then our factors of x minus, I'll use r, and no, I use p and q, sorry. So let's use p and q. So x minus p and x minus q. It doesn't matter which letters we use, but that's what I used, and that's kind of a standard notation. So there is the three different types of forms that we've been dealing with. Now, to write an equation for these, many times what we want to do is, especially this one says on number one, it says use the data to write the function in vertex form. Why is there an extra absolute value bars there at the end? That shouldn't be there. So ignore that little. So that should be a period, not a line. So to write this in vertex form, let's see if we can spot the vertex. So I noticed some symmetry here. So 10 and 10 for the y values, 5 and 5, 2 and 2. The one that's right in the middle of all those, there's my vertex. And so now, if we're going to use vertex form, that's this one. We know h is 2 and k, so we know h and we know k. H is 2, k is 1. We don't know a yet, so we have a function, and this was f of x equals a times x minus 2 squared plus 1. So now we need to find out what a is. Well, you can plug in any one of these points, the x and the y. My favorite is plugging in 0. But any point you can plug in x and y. F of x, remember, is the same thing as y. So if I plug in 5 for my y, and a, and then 0 minus 2 squared plus 1, that's negative 2 squared is 4. So that is 4a plus 1 equals 5. Subtract 1 from both sides, you get 4a is equal to 4. Divide by 4, we know a is 1. So this one had no vertical stretch, just a normal parabola. So my function is f of x is, you can put a 1, you don't have to put a 1. We would just say x minus 2 squared plus 1. And there is the function in vertex form. If we wanted standard form, we'd have to FOIL that and combine like terms. Let's look at number 2. Same type of situation. I see symmetry. I see negative 21 and negative 21, negative 11, negative 11, negative 5. The only one that doesn't have a match, there's my vertex. So let's, f of x equals, I don't know what the vertical stretch is, so we put an a for now. And then we say x minus h is negative 2, so x minus negative 2 is x plus 2 squared minus 3. And we want to pick any point, any one of these points, plug in the x and plug in the y. My favorite to plug in is plugging in 0, so I'm going to put a negative 11 goes where the y is, a times 0 plus 2 squared minus 3. So that's 4a again, minus 3 equals negative 11. Add 3 to both sides, you get negative 8 is equal to 4a. Divide by 4, a is negative 2. So this parabola has vertical stretch of 2 and opens downward, which makes sense when we're looking at these y values, going to negative 11 to negative 21. So this is negative 2, x plus 2 squared minus 3. Like I said, if we wanted to go to standard form, we'd have to FOIL this, distribute the negative 2, and then combine the like terms. Let's move on to number 3. Let's see, for number 3, whoops, I went a little too far. We have a quadratic function. This one's already graphed, so it's the same thing, but instead of a table, they gave us a picture, a graph. But I know what the vertex is. The vertex is 3, 4. And we know the sign of the leading coefficient is negative. And I look, it went over 1 and it did not go down 1. So there is a vertical compression on this one because it went down less than 1. So to find this equation, we're still going to do the same thing. Let's do vertex form. F of x equals, we've got a times x minus 3 squared plus 4. Well, every other time we've plugged in a point. So I need one point to plug in. Let's see. We could use, that point, but I would much rather use 0, comma, negative 2. 0, negative 2 is the y-intercept. Plugging in 0 is always easy to do. So x will become 0, y becomes negative 2. So negative 2 is equal to a times 0 minus 3 is 9. Well, 0 minus 3 is negative 3 squared is 9 plus 4. So subtract 4 from both sides, you get negative 6 is equal to 9a. Divide by 9. Negative 6 over 9 is negative 2/3 is my a. So it did have a vertical compression of 2/3. So my function will be f of x equals negative 2/3 x minus 3 squared plus 4. And like I said, if we wanted a different form, we would FOIL that out. But we are through with number 3 because they did not FOIL it out in the key. So we're going to leave it in vertex form. So we're going to do the same thing on number 4. Oh yeah, the instructions said vertex form. So number 4, the vertex is at negative 2, negative 3. Negative 2, negative 3. I know the sign of the leading coefficient is positive because it's opening upward. So I see a y-intercept of 0, comma 1. So I have an ordered pair to plug in, which means this is also a point. That confused, but we don't need that one. So now let's take our function in vertex form. F of x equals, I don't know what a is, but I know it's x plus 2 squared minus 3. And let's x plus 2 squared minus 3. And now let's plug in 0, comma 1. So y is 1, x is 0. Okay, it can be any point. I just like 0 because it's easy to plug in. It's easy to calculate. So that makes that 0 plus 2 is 2 squared is 4. So that is 4a minus 3 equals 1. Add 3 to both sides. You get 4a is equal to 4. Divide by 4, a is 1. So this one has no stretch. So it's just f of x equals x plus 2 squared minus 3. And we are through with the front side. On number 5, write the equation of the quadratic function with the following so they gave us the x-intercepts this time. So this, if they give us the x-intercepts, I would use root form. So we're going to use the form. We know that x equals negative 3, x equals 4. They gave us that x equals negative 3, x equals 4. So they gave us those values. So if we do the root form, we would say f of x or y, either letter, a times our roots, or our factors, x. If we add 3 to both sides, that becomes x plus 3. Remember, roots and factors have opposite signs. And then this one would be x minus 4 if we move the 4 back to the other side. And we know another point. Plug in 0 for x, negative 12 for y. So negative 12 is equal to a times 0 plus 3 and 0 minus 4. Well, that just gives me negative 12 times a is equal to negative 12. So what's a negative 12? So we know a is 1 when you divide both sides by 12, negative 12. So this function in factored form is just x plus 3 and x minus 4. If we wanted standard form, you FOIL that out. And so this one, let's actually practice that. If we FOIL that out, you get x squared minus 4x plus 1 plus 3x is a negative. Need to subtract, put a negative sign there. Negative 1x, and then positive 3 times negative 4 is negative 12. So x squared minus x minus 12. So we have factored form or root form. We have standard form. To get completing the square, I would want to get the vertex form. We'd have to do completing the square. Write the equation using the following information. We know the minimum value, which means we know the vertex, and we know one ordered pair. So let's use vertex form, since we know the vertex. So f of x is equal to a times x minus 1 squared plus 0, which means we don't even have to put that plus 0, sorry. So I know when you plug in negative 1, you get 8. So we're not plugging in 0 this time. We're plugging in 8 for y, negative 1 for x. So a times negative 1 minus 1 squared Well, -1 minus 1 is -2, and when you square -2, you get 4. So 4a is equal to 8. Divide by 4, we know a is 2. So the vertex form is going to be 2 times x minus 1 squared. If we wanted standard form, we would FOIL that out. And to FOIL that out, leave the 2 factors. That'd be x squared minus 2x plus 1 when you do x minus 1 times x minus 1. So FOIL that out, you get x squared minus 2x plus 1. And now distribute the 2, and you get 2x squared minus 4x plus 2. There is the function in standard form. So standard form or vertex form, we have both. Right? Yeah. Moving on to number 7. X squared minus 5x plus 6. And we want to put it in standard form. Well, they already gave it to us. So y equals x squared minus 5x plus 6. Vertex form, we need to complete the square. So that becomes y equals x squared minus 5x plus something. And we have a plus 6 and a minus something. And we take half of that term. Half of that term is 5 halves, and we square that. 5 halves squared is 25 fourths. So plus 25 fourths minus 25 fourths. So this factors, so where's my, there you go, sorry, the computer was not caught up with me. So y equals, that factors to x minus 5 halves squared. And then that 6 over 1, which is 24 over 4, minus 25 over 4 is -1 over 4. So there's our vertex. We know the vertex is 5 halves, comma, -1/4. Now root form, can you think of two numbers that multiply to be 6 that add to be -5? So it's got to multiply to be positive 6 and add to be -5. So -2 and -3, which tells me the x-intercepts are +2 and +3. So 2, 0 and 3, 0. It is a positive function, so it has a minimum. Domains all real numbers. What other traits? The y-intercept, we'll plug in 0 for x's, and you get a 6. So 0, 6. The range, well, let's plot what we know. We know the x-intercepts are at 2 and 3. The 2 and 5 halves is 2.5. 2.5 and down 1/4 is right in here. So the y-intercept we said was 6. So it goes there and there. Let's see, anything else we need to know for this one? The range is from -1/4 up. So -1/4 to infinity. The axis of symmetry is just x equals 5 halves. And we are, let's see. Oh, there's one more line you can't see. It's covered. I couldn't see it. It's covered up. The roots were the x-intercepts, 2 and 3. So x equals 2, x equals 3. Okay, we are done. That's all you need for this lesson. Good luck to you.